Hello everyone! In this video we will build a stateful MCP server using FastMCP framework, connected to a Postgres database and deploy it to the cloud. I am Anton, the creator of OmegaCloud. Omega is a backend platform that gives you infrastructure, services and workflows to run your application with zero hassle and at a maximum speed. For starters, let's recap what is agent and what is MCP and why we need all this. Let's refer to agentic approach. At the core of any agent, there is an LLM, which we augment with memory, tools, and context. The Model Context Protocol, or MCP, is supposed to standardize the way of interaction between language model or agent and context and tools. On the website modelcontextprotocol.io, we can view a general architecture diagram of this protocol. MCP clients, this could be Cloud AI desktop application or IDEs, tools, agents, or custom-built applications, can communicate via Model Context Protocol with MCP servers that provide various tools, data, context, etc. Today, in our example, we will create such an MCP server which will store and manage small database of our peers' birthdays. This will be an example of our corporate or team MCP server. Let's get started. First of all, I will create a directory for our project and initialize it with UV. I also add some dependencies which we need. FastMCP is our main framework to create MCP server. SQL Alchemy and PsychoPG are two libraries that we will use to work with Postgres SQL database. Now open the code. First of all, let's import our main class from FastMCP and create our application from this class. Since this is our main file, we will run our MCP server. Let's add a name and define transport. In our case, this is SSE, server sent events, and we will run our server with host 0000 on the port 8008. Let's define two functions. Add birthday and get birthday. Add birthday function will allow us to add our colleagues' birthdays. It will take a name and birthday and return bool as a result. Success if everything is fine and false if something is wrong. The get function we will use to retrieve colleagues' birthdays. It will take month type of string, and this will be optional. If it's not specified, we will return all the records we have. The output here will be a list of dictionaries. We import this from typing, and in this dictionary we will have name and birthday. To use this function as MCP tools, we need to wrap them into MCP tool decorators. Great. We also need a database, and first of all, I import environment variables, Postgres user, password, database, host, port. I join them into connection string, and I use create engine from SQL Alchemy to connect to our database. For our application, we also need base class for declarative models, and we need to define our peer model with table name peers and two columns, name type of string and column type of date. And declarative base we import from SQL Alchemy.orm. Great. Let's also initialize our database with metadata create all. when we run this function the first time, it will create our peer table, and if we run this and the next time, it will do nothing. Okay, database is ready. Let's fill our functions with some logic. To add birthday, we'll use sessions. We define new peer from peer class. We add this peer to our session and commit the session. We also import session from ORM. But there is a nuance here. The name is a string argument, and it is a string in database. But birthday is also a string argument in our function, but in database it has date type. So we need to convert it to the date format. We use from ISO format for that. Now let's polish it a little bit and wrap our logic into try except. Okay, fine. Now let's do the same with get birthdays. We also use session, and if month is provided as an argument, we need to convert it into int, and then we get results from our database, querying peer table, where month of our peer birthday is equal to our argument. If month is not specified, we just query all records in our database. Extract from SQL Alchemy. Okay, and we return list of dicts with name and birthday keys. We also wrap this into try and except. And if something wrong, we just return the empty list. Well, our MCP server is ready. Let's try to launch it. To do this, I will create some debug configuration. I call it FastMCP. We run main PI, and we also provide environment file .env. I will create this file right now. Since we're using database for local testing, we'll need to run it somewhere. To do this, I will use Docker. And to use local Docker database in our application, we will need some environment variables. Okay, now let's run Docker. This is fairly simple container startup. Now it runs, and see how it works. We start our application. Yeah, now our MCP server is ready, and to try it, I will use Model Context Protocol Inspector. We use the same parameters to connect to our MCP server. Let's list the tools. Great, we have the same tools as we defined in our application ready to use. So let's try to add some peers. For example, Gregory has birthday on July. Great. And let's say Fatima has birthday on May. Great. If we get birthday without providing any month, we expect to get the list of all our peers. Beautiful. And if we query the July only, we'll get the only result. Perfect. So everything works fine locally. Now let's deploy it to the cloud. For remote deployment, I will use OmegaCloud platform. I will just run Omega run. I go to my personal account, copy and paste my API key. tab of our application is MCP server. It was automatically detected. Fine, we confirm it. We specify domain name for our application, for example, demo birthdays. We launch only the application without any scheduled tasks. For installing dependency, we use UVsync, and to run our application, we execute Python main py. We can also specify the sizing we need for our application. OmegaCloud also detected that we have env file. We don't need to select it here because at the moment the file only contains the environment variables for launching PostgreSQL locally. But since we're going to launch our application together with the database in the cloud, the environment variables for connecting to the database will be different. Since our dependencies include SQL Alchemy, OmegaCloud offers us to set up PostgreSQL database. We agree. And since we chose this option, these environment variables, Postgre user, Postgre password, database, will be generated and sourced to our application on the go. It will take a couple of minutes to start the server and launch the application. During this time, OmegaCloud spins up the server, installs the database, our code will be uploaded to the cloud, dependency will be installed, and application launched. Perfect. The application is launched and is ready to serve at this address. Let's copy. Let's try to use it, but this time not in MCP inspector, but in another MCP client. I will use Cursor for that. We open Cursor settings, go to MCP tab, and add a new MCP server. I name it birthdays peers, and I provide URL of our MCP server with a prefix SSE. This is important since we use a remote MCP server with SSE transport. MCP server setup is complete. Now let's check it. Great. Cursor says everything is fine. The two functions we implemented in our MCP server are ready for use. Let's try them. We enable agent mode in Cursor and ask to add my peer Gregory, birthday on August 8. You see, our request is in unstructured form, but since there is an agentic scheme and under the hood there is LLM working, it was transformed to structured request to our MCP server, and everything was done as we expected. Add one more birthday. This method worked fine as well. Okay, now we can ask who of my peers has birthday in July. Okay, looks no one. And who has birthday in January? And also great. And we remember, if we don't specify months in our request, we expect to get all records from our database. Let's list all peers' birthdays. Great. The second method also works as expected. We can also quickly watch our application logs. In the console, we see all the logs in real time, and we see what's happening, interactions with our MCP server, requests executed, and response statuses. If we had added some additional output via print, for example, we would see them too. I can safely interrupt log streaming with Ctrl+C and leave this application running. We see that the status of our MCP server is still green. I'd like to know that when deploying application to OmegaCloud, you don't need to additionally install or set up databases or any services required for your applications. So we created a stateful MCP server using FastMCP framework, connected it to a database, and deployed it to OmegaCloud platform. In the next videos, we will expand our functionality, add authorization, implement scheduled notifications, and more. Don't miss out. Hit the bell, subscribe, click like, follow us. Register on OmegaCloud platform, get free credits, and use it in your project with ease. I also encourage you to explore other demos where we spin up Fast API server or run diffusion model with GPU. Watch, try, enjoy, stay tuned.